Hello students, see the question student. The gas phase H2O2 structures, it is non-planar structure. You will find the gas phase, the angle you see HOH, it is 94.8 degree, and here is the, in the solid phase it is more, 101.9 degree, so it is there. If you are talking about the bond angle O-O 147, here is solid phase 145 plus, here is OH 95, here is 98. So this is what student. So H2O2 structure in gas phase, dihedral angle, that is how much there is 111 triple 1.5 degree. Dihedral angle means between the two hydrogen angle, between the two hydrogen. If you are talking about the second one, H2O2 in solid phase, it is the 100. So this is what? At 101 Kelvin, dihedral angle is 90.2. That you need to. Chemical properties. It acts as a oxidizing as well as a reducing agent in both the acidic and alkaline medium. Simple reaction are described below. Oxidizing action in acidic medium. So Fe2 plus, it is converting into Fe3 plus. PBS, it is converting into PbSO4. Okay. So S2 minus, it is converting into SO4. Reducing action in acidic medium, MnO4 minus, it is treated with the H2O2, it is converting into Mn2 plus. HOCl is there, it will convert into Cl minus. Oxidizing action in basic medium, Fe2 plus 2, Fe3 plus, Mn2 plus, Mn4 plus, I2 I minus, MnO4. Okay. Basic medium MnO4 minus, it is converting into MnO2. Storage, H2O2 decomposes slowly on exposure to light. 2H2O2, it is giving the 2H2O plus O2. In the presence of metal surface of traces of alkali present in the gas container, the above. The reaction is catalyzed. It is therefore stored in the wax lined glass or the plastic vessel. In dark, urea can be added as a stabilizer. It is kept away from the dust because dust can induce explosive decomposition of the compound. What is the usage, student? So its wide scale used has led to tremendous increase in the industrial production of H2O2. First one, in daily life it is used as a hair bleach, as a mild disinfectant, as an antiseptic. It is sold in the market as a perhydrol. Second one, it is used to manufacture chemicals like the sodium perborate and percarbonate, which are used in high quality detergent. Third one is there, it is used in the synthesis of hydroquinone, tartaric acid, certain food products and pharmaceutical, cephalosporin. It is employed in the industries as a bleaching agent for the textile, paper, pulp, leather, oil, fat, etc. Fifth, nowadays it is also used in environmental green chemistry, for example in pollution control treatment of domestic and industrial effluent, oxidation of cyanides, restoration of aerobic cyanides conditions to sewage waste. Heavy water, it is extensively used as a moderator in the nuclear reactors and exchange reaction for the study of the reaction mechanism. It can be prepared by exhaustive electrolysis of water or as a byproduct in fertilizers industry. Its physical properties are given in table 9.7. It is used for the preparation of other deuterium compound like CaC2, D2O is there, C2D2, COOD twice, SO3 plus D2O, D2SO4, Al2, Al4C3 plus 12D2O, CD4, 4AlOD thrice. Dihydrogen as a fuel. Dihydrogen releases large quantity of heat on decomposition. The data of energy released by combustion of fuel like the dihydrogen, methane, LPG are shown. So here you see the fuel per mole there. What are there, student? Dihydrogen 286, but here In the liquid phase 285, LPG 2220 kilojoule per mole. Here is 880, octane is there 5500 111 per gram 143 142 50 53 47. So per gram it is the highest. Per liter it is the lowest. The energy released by combustion of various fuels. So in per gram it is the highest, student. The amount in mole, mass and volume are shown in table. From the table it is clear that on a mass basis, dry hydrogen can release more energy than the petrol, about 3 times more ever pollutant. In combustion of the dihydrogen will be less than the petrol. The only pollutant will be the oxides of dihydrogen due to the presence of dinitrogen in the impurity with the dinitrogen. This is of course can be minimized by the injecting a small amount of water into the cylinder to lower the temperature so that the reaction between dinitrogen and dioxygen may not take place. However, the mass of the container in which dihydrogen will be kept must be taken into consideration. A cylinder of compressed dihydrogen weight about the 30 times as much as tanks of petrol containing the same amount of energy. Also, dihydrogen gas is converted into liquid state by cooling to the 20 Kelvin. This would require expensive insulated tanks of the metal alloy like the NaNi5, Ti, TiH2, Mg, MgH2 etc. are used for storage of dihydrogen in small quantities. These limitations have promoted researchers to search for the alternative technique to use the dihydrogen an efficient way. In this way, hydrogen economy is the alternative. The basic principle of hydrogen economy is the transportation and storage of energy in the form of liquid or gaseous dihydrogen. Advantage of dihydrogen economy is that energy is transmitted in the form of dihydrogen and not electric power. It is for the first time in the history of India that a pilot project using dihydrogen as fuel was launched in October 2005 for the running automobile industry. 5% dihydrogen has been mixed in the CNG for usage in four-wheeler vehicles. The percentage of dihydrogen will be gradually increased to reach the optimum level. Nowadays, it is also used in fuel cells for the generation of electric power. It is expected that economically viable and safe source of dihydrogen will be identified in the years to come for its uses as a common source of energy. So this is there, student. So this is all about the hydrogen peroxide and dihydrogen, student. Thank you very much for watching.